And it's your lucky day. We're going to do lesson 4, which is the last lesson before our test. There are a couple different concepts in here, and so you want to pay attention to making sure that you feel like you know how to do each of the concepts that we come across. So we're going to be rewriting formulas. We are going to solve problems using verbal models. That's a fancy way of saying word problems. And we're going to do unit conversions. So there's really 3 in 1. It's like your lucky day. So you have 3 separate sections. All of these concepts to some degree are review, which is why we're covering them sort of together and kind of hustling through them, because we're going to get to some more exciting things for chapter 2. Keeping in mind that a formula is an equation, so you can expect an equal sign that relates 2 or more variables. When you are told to solve for an equation or solve for something, so it might say solve for X or solve for Y or solve for capital A, what that means is to get that variable alone. So if it says to solve for Y, I need Y equals whatever. If it says to solve for X, I'll need X equals whatever. And so to do that, I have to undo what's there. So I usually think, okay, I'm going to ask myself, how is it attached? That's not one word. So how is it attached? Meaning whatever you're trying to get rid of. How is it attached? And then how do you undo that? So you have to think, how do I undo that attachment? So with addition, I undo that using subtraction and so on. So for example, here it says solve the formula C equals 2 pi r. So there's your good old circumference formula from geometry for r. So I'm getting the r alone. So think about C equals 2 pi r. How is the 2 and the pi attached? Through multiplication. So to detach it, I'll need to divide, and whatever you do in mathematics land, you have to do to both sides so the world stays fair. These cancel, and then r will be equal to the circumference divided by 2 pi. And that is all we're doing. So we're rearranging the equation. We're not really doing any calculations. So solving seems like such a strange word, but here to solve for little b means we need to get little b alone and get everything else away from it. So the first thing I'd probably want to get rid of is that 1/2. To get rid of a 1/2 that's attached, you're going to divide by 1/2, which is the same as multiplying everything by 2. So I'm going to multiply this side by 2 and this side by 2. That's gone. So at this stage, I have 2a equals b times h. I'm still trying to get b alone. So since h is attached through multiplication, I would detach it with the opposite action, which is dividing. So my final rearrangement or answer is that b will equal 2 times a over h. And the little triangle guy is there because that's your area of a triangle. So you don't have to memorize those formulas. You just need to be able to practice moving the things within it around. What we will do more often is formulas like this. We're going to get into linear equations in the next chapter. And so this is asking you in really teeny tiny writing. Your final answer should be in slope-intercept form. So dig deep into your brain. That's asking you to get y equals mx plus b form. So when I take this equation 6x minus 4y equals 12 and solve it for y, I'm going to get y alone, which will then look like the slope-intercept form. So to get the y alone, I can't get rid of the negative 4 first because it's attached. So that's going to actually be the last thing to leave. The first thing to leave would be this, which is a positive 6x. So I'm going to remove it by subtracting it to the other side. Keeping in mind that my goal is to have this formula. So I currently have negative 4y, and then I'm going to put the negative 6x in front of the positive 12 that was already there because that's getting me closer to the mx plus b. Now to get the y alone, I'll go through and separate that out by division since that was multiplied in. And my final rearrangement is that y would equal, now look at this, it's going to become positive, and I'm going to reduce that to 3/2. And then here, the 12 over negative 4 would reduce to a negative 3. So that is rewriting it in slope-intercept form. That's a skill that you're going to have to use. in our algebra future. So this one's a little tricky. I have 2y plus xy equals 6, and I'm trying to solve it for y. If I were you and I had a test next week, I would probably put a big old circle around this, because anytime I come across something in my notes that's a little tricky, that shows up in my homework and then shows up in the review, I know that it's something that I'm probably going to see on my test. What's tricky about this is you're trying to get y alone, but it's spread out everywhere. So you have to think about how you could get it to be just one y instead of spread out everywhere. So think about papers. If I distribute papers, then they're everywhere. Everybody has one. And if I don't want them to be everywhere, I would have to collect them back up front. So what you're really doing is factoring out a y, saying, hey, everybody has a y, so pass it forward. That would leave this term as a 2 and this term as an x. But what's lovely about that is now the y that I'm trying to get alone is multiplied by something. So to get it alone, I would divide it by that same thing and just divide the other side as well. So this is gone, and I've accomplished my goal of getting y alone. Be cautious. Don't be tempted here to reduce that, because you have to be able to reduce. I always call it triangle reducing. Every piece has to reduce in each corner or you can't touch it. So in this case, I have the 6 on the top and the 2 plus x stays on the bottom as is. So that is a problem. Watch for that on your homework and make sure you're practicing that to a degree where you'd be comfortable doing that on a test or a quiz. All right, same thing here. I love this problem. You are hanging 5 posters in the hallway at school. All righty. The posters are 3 feet wide and the hallway is 39 feet long. There should be an equal amount of space between the ends of the hallway and the posters and between each poster. Geez Louise. So the question is, how far apart should the posters be placed? So the thing we're looking for is x, and that's going to be the space between the posters. So on my homework, I know it's going to ask me for a diagram, and it's going to ask me for an equation, and then it's going to ask me to go ahead and solve to find that distance between them. So go ahead and draw yourself a diagram. If this is the hallway, what do I know about it? I know it's 39 feet long. I know that I'm hanging 5 posters. So I'm going to have 5, 1, 2, 3, 4, 5 posters. Each one is 3 feet long. And then it says there should be an equal amount of space between the ends of the hallway, so that's here and here, and the posters, so here and here, and between each poster. Okay, so all of these are the same, so all of these are x if x is representing the space between. So that is my diagram. So what's my equation? Well, if you look at this diagram and think about what's happening, you have 1, 2, 3, 4, 5 posters that are 3 feet each. 1, 2, 3, 4, 5, 6. Plus, I'm going to have 6 spaces that are x feet, and they have to add up to the total of 39. So my equation would basically be, and if I'm going to write it in a more familiar form, 6x plus 15 equals 39. So if I'm told to draw a diagram, check. Equation, check. Solve, well, that's usually the easiest part. I'll go ahead and subtract the 15. 6x will be 24. Dividing, and I find that x equals 4. And then looking back up here at what x represents, is asking how far apart the posters should be. And in this case, they're all the same. So they should all be 4 feet apart. And so I'm making sure that I have a label that says I know what I was solving for. Okay, so going back and looking at our list, we have rewritten formulas. That was that first part where we got them alone. And we looked at a couple of places where we used verbal models. Now, there's a couple more word problems we will get to, but our third topic is unit conversion. Again, something you have done. And since that's coming up next, we'll just go ahead and do that. So You travel for 150 minutes at 50 miles per hour. You have to really pay attention to all of these units because that's what makes these kind of tricky. How many miles did you travel? So I always use what I call the domino effect. I set them up so that they can tip each other over. And if you've never played dominoes and you have a domino here that's got like 1 dot and then 3 here, you need to set it up next to one that has 3, and then the 3s basically cancel out. And if the next one has 4, you're looking for a 4. So if you have no idea what I'm talking about, totally ignore that part of the video. So I am starting with 150 minutes and I'm trying to convert. You can set them up as a series of parentheses like you might do in chemistry or science class for stoichiometry. I do like a big track. So now if I have minutes on the top, I need minutes on the bottom, and I'm trying to convert to hours. So if I need minutes on the bottom and I'm trying to convert to hours, I know that conversion. 60 minutes is 1 hour. And then I can cancel out minutes and I'll be stuck with hours. And so that is kind of where I'm headed. Okay, but now this is 50 miles per hour. Okay, so I have to incorporate that somehow. Now, I have hours on the top, so my hours will need to go on the bottom. 50 miles per hour has to go in there. But now again, my hours can cancel because one's on the top, one's on the bottom. I am trying to get miles. It says how many miles. So I kind of feel like I'm done because I have miles up here and all my other conversions or units have canceled out. So now what I'm going to do is I multiply all the way across the top. So I'm going to take my 150, I'm going to multiply that by 50, and I'm going to get 7,500 on the top. Keep in mind that's miles. And then on the bottom, it's over 60 because 60 times 1. So when I reduce that through division, I end up with 125 miles. So you're kind of just doing a little chain of information until you land on what they're looking for. So I used my conversion here to switch to hours as kind of my link so that I could get rid of the hours in my 50 miles per hour. All right, let's try another one. You drive 45 miles per hour. So I'm starting with 45 miles per 1 hour. That's my rate. Okay, I used that. What is your speed in feet per second? So I have to take my time going through here. Now, a conversion you may not know and you should know, so kind of highlight this in your notes, is right here. I need to go from miles to feet. So there's my conversion. The portion of that conversion I need on the bottom has to be miles so that they can cancel. So I'm putting my 1 mile equals 5,280 feet next in my conversion, because then I can look at my units and say these miles cancel these, and I'm at feet, which is what I'm trying to get. So that means I have to deal with the time because my time is still in hours and I want it to be in seconds. So let's do some converting of time. If I have hours on the bottom, maybe I would use a 1 hour to 60 minute conversion. Then these hours would cancel, but I don't want hours, I don't want minutes, I want seconds, it says. So then I get a conversion between minutes to seconds, and I have to have that so the minutes are on top and can cancel. So I would write 1 minute is 60 seconds, and now the minutes cancel. So I finally have what I'm looking for. What I'm trying to get is feet on the top per second, feet per second. So now that I have the units I want, I just go across the top and multiply those values. So 45 times 52, 80 times 1 times 1. So that's nothing in terms of change. So that's my top, and my unit is feet. And on the bottom, I've got a 60 times 60, so that's going to be 3,600 seconds. And then when I do that division, I end up with, oops, I made a mistake on my calculator, sorry. So 2, 3, 7, 6, I can't even see if that's 0, 0. So then I'm getting 66, and that is feet per second. So if that's not super crystal clear, highlight that, because that is definitely something you need to know how to do. So like you already know, you want to look carefully at a problem like this. You want to make sure you're comfortable with the conversions. You want to make sure that you can do one of these where the variables spread out. There's a lot of very honors level things in these notes that you want to pay attention to. Okay, if you need a little break, take a little break, but we're going to look at 2 more types of problems. This is what I'm going to call in class a work together problem. And a work together problem is going to be something you definitely need to know. Last year I kept saying, make sure you know the work together problem, and then a whole bunch of people did not know how to do the work together problem when it came crunch time. So don't let that be you this year. I'm absolutely flat out telling you, you want to know how to do these. In a work together problem, you're going to be given 2 people or 2 things that are going to work together, thus the name. So for example here, let's say you can wash 3 cars in 42 minutes, and your friend can wash 5 cars in 1 hour. Write an equation, so I'm going to need an equal sign, that would represent the number of cars, and I'm supposed to use a capital C, not an X, that you could wash if you work together. Okay, so let's work on that, no pun intended. So we have to end up with a C that's representing the number of cars that you are working on. So you can do 3 cars in 42 minutes, and then we're going to multiply that by X. If that's cars per minute and we want cars, we have to get rid of the minutes part, because if I have cars per minute, I would need to multiply by minutes to get that out of there. So X is going to represent time in minutes. So then the other person, now you have to be careful because this is 5 cars in 1 hour, but we're doing our whole problem in minutes. So instead of 1 hour, I'm going to write that as 60 minutes times X in minutes. So this is representing the 2 different people in this case. This is me, and this is my friend. Okay, and this is us working together. And all that this part says is to write an equation. So I'm writing an equation. But down here it says, now determine how long it would take. Since X is time, this is basically telling me to go ahead and solve for X. So pay attention to this. Pay really close attention to this on the tests. If it says to round to a certain value, you need to round to that value in order to get full credit, especially when you're doing online work and you're going to type in an answer. If it says round to the nearest hundredth, you're going to need to have that exact value. Okay, so I'm supposed to solve for this when C is 12. So I'm going to start with 12 equals 3. You know what? I'm going to reduce these fractions because they're already kind of horrendous. And so I'm going to reduce that. And when I reduce that fraction, I can go to my calculator. If you have a graphing calculator, do 3 over 42, hit the math key, and then enter, enter. And it's super slick, and it's going to reduce that for you so that you can have 1/14 X plus here, and you probably already know what this is, but if you do 5 over 60, then hit math, enter, enter. Super slick trick if you have a graphing calculator. You go to math, then there's a math key over on the left up kind of towards the top, and then you hit enter, enter. I'll call that enter squared. And it'll reduce your fractions for you. Lovely, super fun, thank you. Alrighty, now I've been telling you that we are going to do fraction problems. We saw them in the equations, we see them in the inequalities, so here you're seeing it in a word problem. Absolutely know how to do these. You can do them as fractions, but the recommendation that I've been giving you is to find a number they both go into. So I did a little prep work and I found that they would both go into 84. So for time, I'm just going to go ahead and tell you that. So if I multiplied everything by 84, including the 12, don't forget that one, I'm going to get 1008. And then here, I'm going to get 84 over 14x. And here, I'm going to get 84 over 12x. If I've done this correctly, like I've been saying in class, if you take that fraction and divide it down, it better come out to be a whole number. Same with this other one. If you're still stuck with a fraction, then you picked the wrong value. Now I can solve this with whole numbers and have 1008 equal to 13x. And then divide that out, keeping in mind that the instructions told me to round to the nearest hundredth. And on my calculator, this is what I see. Nearest hundredth is 2 decimal places, but the 8 is greater than 5. So I'm going to round it off to 77.54, and that is in minutes. So that problem is something that you want to know how to set up, and they're always going to be set up the same. You'll see them in your homework. You'll see them in the review. So make sure that you are kind of understanding how those go together. All right, finale. This is called the grand fish finale. You want to buy 25 fish for your aquarium. You decide to buy, I assume that's Danios, tetras, and rainbow fish. I'm not a big fish connoisseur, so I don't know a lot about that. You're going to write an expression. Keep in mind that that means no equal sign for the total cost of D Danios, T tetras, and the rest of the rainbow fish. No need to simplify. Okay. The directions imply that you only use 2 variables. So the problem is I don't have a variable for rainbow fish. I don't get to use just an R. So they're saying you're going to have your Danios plus your tetras plus your rainbow fish, but you don't have a variable for that. So you're going to have to figure out how to represent that, and that's going to add up to 25. So this is kind of like the underwater camera problem where you knew that you had 20 altogether, but some of them were regular and some were underwater. You have to figure out how to represent these rainbow fish in these other variables. So get it alone. So back to what we learned at the top, the rainbow fish would be 25. Then you'd have to take this away to the other side and take this T away to the other side. So when I'm representing the number of rainbow fish, it's going to look like that. So my expression for the number of them, for the cost is going to be, now here's your cost. Be careful. I'm going to pay $1.50 per Daniel, plus I'm going to pay $2 per tetra, plus I'm going to pay $8 per rainbow fish, which I'm representing as 25 minus D minus T. Now, this, normally I would have to go further, but if you read this, it says right up here, reading the directions is so handy, there is no need to simplify. So at this point, I am not going any further than that, and that is going to be my final expression for the total cost. I didn't write equals cost because it's an expression, not an equation, and I don't have to simplify it, meaning I don't have to distribute, I don't have to combine like terms. So, wow, that was a lot, but now you should be able to say, okay, can I convert units? Am I able to do the problems? What kind of problems will I need to know how to do? Well, I know for sure I need to do work together problems. I'm probably going to have to do kind of like the poster problem because that was in there and got highlighted. You know, I'm just going to have to kind of do some cost of items problems. So everything that you see in the notes is something that you want to become an expert on. So watch parts over again if you need to. Otherwise, you're going to be just working on the homework for this lesson 4. And then we'll be having a review worksheet and a review quizzes, not a quiz, but the quizzes app that allows you to answer questions on your iPad.